Since your enzymes follow different types of mechanism, the two-step mechanism, three-step, four-step, and other mechanisms, it is convenient to define a more general rate constant for the overall reaction. And this is the K-cat, or the turnover number. So it has or it is a measure of the catalytic speed of the enzyme, and this is dependent on the rate constant of the rate limiting step. The reason why it's called the turnover number is because it is the number of processes the enzyme catalyzes per unit time. Again, this depends on the mechanism followed by the enzyme. So we are focusing on the two-step mechanism postulated by Menten and Michaelis. So for that two-step mechanism, our Kcat is equal to K2, the rate constant for the second step in the mechanism. And we can actually write a relationship between Vmax and Kcat, because Kcat is equal to K2. Then we can write Vmax equals Kcat times the total concentration of the enzyme. So we can see that Kcat is a first order rate constant. So because your second step is a first order reaction, so it depends on only one term, one concentration term, which is the total concentration of the enzyme. That is why we have per unit of time as the unit of Kcat. So in this table, we see some values of Kcat. We see here carbonic anhydrase, which has relatively high values. So if it catalyzes the conversion of carbon dioxide to bicarbonate, then we have 1 times 10 raised to 6, meaning it catalyzes or it performs the catalysis 1 times 10 raised to 6 times per second. Now, in terms of catalytic efficiency, we have what we call the specificity constant, and this is the ratio of your Kcat or turnover number and the Michaelis-Menten constant. So this is another rate constant. This time, this is a second order rate constant, and we see that the units for the specificity constant is per unit of concentration per unit of time. That is why it is a second order rate constant. So this one tells us the efficiency of the enzyme. So if it interacts with a substrate, it doesn't necessarily mean that it proceeds to produce the product. So we see here that the range of your specificity constant is 10 to the 8. And actually, there is a ceiling observed, ceiling value for the specificity constant. So they say that the maximum specificity constant is in the order of 10 raised to 8.